to a bar.
Live streaming
Well,
is on.
it's right next to a bar called Brewers. So
I'm
you've
not
got this
familiar with
corner
that.
where you have Brewers and Perks right next to each other.
I know there's a Brewers pub you talking
Yeah,
about?
the Brewers Pub, right?
Yeah, I've been in there.
Yeah.
It's
So
very
I'm starting
well.
to think of that. I think of like beer and coffee, like right.
Yeah. And you get Trano's right there too, right? Trano's?
Yeah, the pizza place is next to the
Yeah,
Italian place. Yeah, Drino's Italian, right next door.
exactly. Yeah, yeah.
Yeah, that's the third thing
You're
down.
the center of commerce there.
Yeah, I've never been in Trino's.
Oh, now it's very nice. They have a. It's a lot more than pizza. There's some really good meals they have there,
Yeah, I
and
know they got a nice sized parking lot and stuff.
and they have a nice outdoor facility when the weather gets better. So,
Right. Cool.
yeah.
Hey, George.
Oh, hi everybody. Just getting my day started here. Little scrumbled.
You must be retired.
Yeah. Wish I could afford to be retired, but it has its upside.
Oh yeah. Yep.
Marble College, yeah.
Okay, I guess it's looking at the clock. It's 11:08, so I guess we'll just start here and just keep going until like more people show up.
Yeah.
All power to us. If they don't, then whatever. So hey guys, welcome to the Math Counts meetup. We're just doing a general discussion this week or this month because I'm trying to introduce myself back into things a little bit after not doing this for so long. And I was kind of hoping that we could just like have a good discussion about what is mathematics, why do we use mathematics, and then I'm hoping from you guys to get a sense of like what's been happening a little bit more in the past few years and what people might want to see going forward as well for the basics of it. Let me pull up notes here. Maybe. So it's a the actual question itself, what is mathematics, is a fairly broad question. Like it's an old meetup that's been I think it was like one of the first ones we might have done, and it's come up a couple times as just a good way to hopefully get general discussion going and just get people's views on what's happening a little bit. So on the website in my description, I started asking some like questions about like how can we break the question down of what is mathematics, and started asking questions like, is mathematics the calculations that we do? Is it the logic that's underneath the actual underneath everything? Like what can we even consider mathematics at that point, and who can we consider mathematicians? Of course there's the actual classic. I'm also getting used to Jitsi itself as a tool, so we're gonna see how this goes, because it might just act strangely on me a little bit and I might react to it. So I guess for right now I'll just open the floor up to anybody who might want to like actually throw in their thoughts on the question.
Well, I'd like to start by saying that all I can think of when you ask that question, as a former school teacher for public school teacher for 7+ years, one of the things that questions I've always heard is from students is, when am I ever going to use algebra? Why should I study it? And I think that question is indicative of mathematics itself, in that many times people do mathematics and there's no direct application for it, but they go off and study some very complicated and subtle relationships. And it's not until much later that they find there's an actual physical application to it. So to that extent, uh, I think that's very interesting. And the other thing is that, of course, I think the mathematics in general is supposed to be used as proof that something exists, that a relationship exists. Now, whether that's true or not, I don't know. Because when I was down in Arizona, I went to one of these Indian reservations, and they had this building there that was sort of like a astronomical building. Well, and this had a few holes in it, but the holes were there as a calendar. And when the sun shined through the hole, they knew it was time to plant. And when it flew through another hole, I guess they knew it was time to harvest. I don't know if that's the truth, but they did have like a calendar, and those people and the Mayans and many Greeks and Chinese and Koreans all had calendars that they thought were revealing the truth. And as time went on, even though they worked, they were not exactly right. You know what I mean? In other words, they had false assumptions that, when put together, gave them the information they needed. I just thought that was I always find that amazing. And so, and for some reason, I feel that, well, that doesn't apply anymore because we're much sharper than that. But I don't know whether we are or we're not. But I think that we all need to have time to check our assumptions and make sure that we're moving forward. And I think in this particular class, I thought, it's like, what do you remember the ones where we did on number theory, and they came up with all these strange relationships, and it was really interesting. I don't know where it went, but it was just fascinating, and it kind of gives you the feeling like, hey, maybe there's some order in this universe. Whether there is or not, I don't know. But some things seem to work, and we like that, and reproducibility, of course, is the whole thing.
So I think Craig's covered a lot of the big issues in a certain way. I like where you took it, Greg, which is maybe that's one of the best definitional aspects of math I've ever heard, is whatever you're showing people that they don't want to learn. That's probably how we can define mathematics, because it's like the question, what is math? What is science? There's a social definition that the group of people doing it, will define what is mathematics, and the rest of anything else is astrology, right? So, but your starting point points to the fact that everyone, like, what is science? Every kid is a scientist. Everyone knows every kid is like doing science by sorting through, eliminating the things that aren't true, finding the truth. And so we're all doing math all the time. We're making sure this is the right one, and the number of things are here. We're all doing it, and we're making sense of the world that way. But when you examine that process, that's what nobody wants to do. Mostly nobody wants to. But mathematicians want to see, what are we doing? So it's kind of an examination of your own thinking. So that's why sort of logic kind of falls in, but out of math, it's even more general. But it's like, maybe it's math. We'll call it math because the mathematicians call it math. We'll call it math. But it's reviewing your own accounting for things, doing the bookkeeping, which is building the temple. You're using math, but I don't think you're doing math. You're kind of, that's not math, but you sure as heck are relying on the fact there are mathematical truths. So I thought that was a very interesting survey of math being used, but not doing math, but then recording. Like, now you're bookkeeping, and now you find rules, and now you express the rules. Now you're thinking about what you just measured, and now you're really getting close to not just physics and the calendar, but why is this adding up? What is the regular? What do I see going on? And that's something closer for me to what a definition would be. But if you don't enjoy it or it's threatening, maybe that's a big clue. Because you're not going to ever get the answers to everything, right? But I love math. Okay, so you also said, why you like it, an inspirational aspect to it. Yeah, like we feel like we're grasping onto something really true. The slippery rods, this one I can like actually hold on. So it has some internal beauty and truth that is self-affirming. These systems make total sense and they really, really work. And I know what's in and out of the rules, and I can, force my brain to be smarter about it. And it's a real awareness of your own power to like use raw ideas on themselves. So I love that. Now, the fact that it might apply to the real world is awesome. I mean, that's one of the reasons I'm attracted to it. It's like, you could probably say anything in mathematics. Once you discover something new, you could probably, if you're a mathematical thinker, transform it into a statement that now you can transmit and as a solid factual form that people will be able to also use as an idea. I love that. It's a language we form by our experience and the certainties we make out of it, but it has its abstract power. Once you've done that, the rules in it let you play with it and find other true things. It's incredible. So if it's true about the world, you can discover all kinds of things about the world. And the last thing I want to say was it's a really good language because as much more of it you learn, the more you can read other people's ideas about really interesting, cool stuff that you otherwise wouldn't have access to. I can't read biomedical crap. I'm like, there's a chemical, and I know chemistry. Like, I even taught chemistry, but I can't read about, limbic systems and, applied physiology and the chemistry. I just bored that shit. But if it's an article about astrophysics, something obscure, and it's got math, I can sort of piece my way. I can see what they're talking about. It means something to me. So it gives me access to really interesting things.
Mm-hmm.
Okay. This morning I was thinking about this question and I typed up a quick definition. So I'm going to do a screen share and bring it up.
The answer. We're sharing our work. Just like usual.
Yeah, just like usual. All right, we'll just.
By the way, I'm gonna have to leave a little early. I have to go.
All right,
to the family.
Can you guys see that?
Yep.
Okay, good. I'm going to read it real quick. Mathematics is the study of conceptual objects, their properties, relations, interactions, groupings, and structures. All these objects are inspired by real-world objects. Now, abstract mathematics is the field of study which primarily concentrates on these objects and properties, etc. Applied mathematics is the study of real-world analogs of these objects and the application of information about these objects to the real-world analogs. Short version, math is the study of things that does not exist and applying it to things that do.
It's very general. Let me ask you something. How would you distinguish that from sociology, which is about relations, interactions, and groupings and structures of animals working together and looking at those objects and their properties and studying how they apply to the real world? It would fall under applied mathematics, but it's not. How would you rule that out? Or,
Dave, I would, after listening to you and Sam and Greg talk, I would actually add a third little section, which I would call engineering. And that is purely the cookbook application of some of these things. Whether you're a programmer or a software engineer or a real engineer building a building, you're just using the formulas. I think sociology is, I would put in that thing where you're actually looking at these real world analogs and trying to apply. You can apply mathematics to sociology. Biostatistics do it all the time. People like that. But again, that's to study these objects, and you're not really trying to make that jump over to the conceptual side. Does that answer the question, Dave?
Well, I'm trying to think. I mean, what is a human is a sort of, there's no Mathematics is the study of conceptual objects. Okay, I'm nitpicking, I guess, just to see with these kinds of ideal objects. Yeah,
Right,
ideal.
ideal. In fact, maybe ideal would be a better word. I should change that. I kept flipping back and forth between abstract and conceptual, but ideal
Yeah,
might be the word I'm looking for.
yeah, yeah. I get you. I get what you're saying. Conceptual is a great word. I like it. I like it.
Yeah.
It's a cool definition.
I'll suggest another way that sociology is applied math is graph theory.
Okay.
Bob knows George, George knows Dave, does Dave know Bob? That's like an incomplete graph. But so you can abstract those human relationships into a mathematical pattern.
Okay, great.
Well, you can turn anything into mathematics, but I don't want the definition to turn things that aren't math into math.
I'd like to add to that, Bob, if you don't mind. I think, like right now, we live in a Newtonian world, and I've been taking this class in quantum physics, and all I can tell you is, the idea was I was trying to bring myself up to date, okay, with what's going on, and Newtonian physics falls apart when it gets down into the nitty gritty, into micro particles, and you have like these different things that come up, like what is it, Schrodinger's cat, that is alive and dead at the same time, that kind of thing, and that kind of thought. I think that's very, very fascinating, and I'm not trying to set an agenda, but I think there's something to be said for trying to kick it up into the 21st century. And when I think about that, I think about the way we looked at the universe. We remember when people couldn't figure out what the heck was going on with light. Is it a wave? Is it a particle? Or what? And then they said, well, because they assumed that through their logic and their assumptions that space was empty. And so, but that could be impossible because it couldn't travel. So it had to have this ether in there that had traveled through the ether. Then the ether was removed when they said, well, light is going to be both a wave and a particle. And then now we're saying we don't really know what the universe looks like because it's mostly dark matter and dark energy, 95%. In other words, we don't know about 95% of the universe about what's going on. But they look at that as they say, well, look, these evidently that the dark matter has a mass that's discernible, and that's causing different objects to move because of the mass of that dark matter. Well, all I'm trying to say is there's a lot of mysteries going on out there, and many times we really don't we don't put in the time unless it's dedicated to try to deal with it. And it's almost like a fantasy world because I don't know if you guys look at the way with quantum physics, how there's different particles, like the atom, for instance. The atom is not just the atom. You have these like electrons, but the electrons are not really like electrons. They're things that's moving around, energy that's moving around. And
but a lot of it is abstruse physics and stuff. It's like dark matter. The reason it hasn't been focused on is because it has virtually no effect on our everyday experience at all.
Yeah, unlike an apple hitting you on the head, right?
I mean, if it were a little more prominent, either we'd have dark matter components, or we would, have to study it to make wheels work and stuff. But yeah, you're right. It's like you want to know the fringe of everything, so you start to look and you realize I only know like a couple functions and a few numbers, and like most of nothing is what I know when you really look at it. Like we can't even name most of what's in mathematics, and it's humbling.
Well, think about how it affects your everyday life. You're wondering how it affects your everyday life? I'll tell you. because with the advent of these in dark matter and energy, they're now saying that the universe is expanding. Okay, and what that means, and they're all not only say, well, it's going to expand, and then just go out into the cosmos universe where it's so cold, and things are just going to freeze. And I mean, and that in your mind is like, oh Christ, what the, you know, that doesn't sound like much fun, because for years they were saying it was going to collapse. And I'm thinking to myself, oh, I love the idea of collapse, because if the universe collapsed as we used to think and go to a singularity and then have an explosion or something, and you can start all over again with the same matter, and then we can make the same mistakes for all eternity. So I
It
think
doesn't.
that
I'm
kind of
asking,
be a warm feeling, you know?
yeah, you're talking about the whole universe and its properties, and
Yeah.
I'm asking. That's a conceptual thing.
Well, my point is simply that these things, although they're not affecting us directly,
Yeah.
can affect your attitude as to what the future's about.
Mm.
I see. Right.
You know?
I think learning mathematics the way we do, we are kind of concerned about what's the significance of everything we're learning, like
Yeah.
the Platonic solids, the nature of space, the constraints on the answer to things. Yeah, I mean, I think we do that. Arisi math does that, and that's why we love it, right? It kind of gives us insights into how you can say two contradictory things, and there can be a truth in the middle of it, or so like even logic is more complicated than you think it is, right?
Well, logic is only as good as the assumptions it's based on, right?
Something you brought up, Greg, which kind of made me laugh
Uh-oh.
when you mentioned quantum stuff.
Yeah. I got to laugh too.
Is that
Because George and I have been studying the quantum mechanics in reference to quantum computing. And one of the things we found was that the stuff those physicists do that they're calling mathematics isn't math.
Right.
What
That's
they do is they use a math symbol to label a physics concept. But that symbol isn't necessarily the mathematical concept.
Yes, and that's a very interesting point. That's one thing I got out of this.
You try to read these equations, like I would read an equation as a mathematician and say, this equation describes the universe to me, gives me the context, right? I can see what's going on from reading the equation. In quantum mechanics, you read the equation, you have to know the context in order to understand the equation. You can't get the real world from the math symbols they write down.
Like, what is an example of that? You mean the operators mean something specific to the configuration of this experiment?
Yeah, and they overuse them or they define them in bizarre ways. They change the definitions all the time. So that I go to a physicist and say, this equation makes no sense. And the physicist says, sure it does. If you understood the physics, it would be perfectly clear. So you can't get the physics from the math. And math they're putting down isn't the same as the math that we use.
Are you sure? Like, what examples do you mean?
I'll give you an example. Their definition of eigenvector. A equals V times V.
A equals Z.
Actually, I'm going to say AV. Yeah, the linear operator describes an eigenvector. A equals V times V. And a physicist says, I said, what is this? Right? He says, well, this first V is the eigenvalue. It's a constant. This second V is the eigenvector. We often use the symbol for the eigenvector as the eigenconstant and vice versa. And if you knew the physics, you would understand that equation. That this V is is what we call lambda. And this other V would be something we would call a bold V.
Oh, they don't use a bold font and a plain font.
Right. And this is work that's been published like 10 years ago. Professional in a book. Right. And so you have to know what that symbol means based on the context of the physics.
Yeah, that's the weird thing I found in studying this subject area is that these scientists go out and get stuff, and it's not necessarily how you say something that can be explained mathematically. They know it happens, but it can't be generalized. Just like when Newton does his work, everything he did could be generalized. But in physics, it's like this is the event, and we're going to identify it as an event, but what can you deduct from it? Can you make a generalization because of this event? And that is like, forget about it. They're still
Right.
searching for shit, you know?
Yeah. So it's a really weird. Quantum is like a really weird thing. I don't think they actually have a mathematical language to describe it properly,
No, I don't think so either.
and they used what they have as labels,
Exactly. They
not as the actual mathematical operator or concept.
have to get to that point, but
Right.
it's like a dead end.
Yeah. So it looks like math on the surface until you try to do it. I'll give you another example, Dave. They have the idea of a set of basis vectors. They use a ket, which is a straight line and a greater than sign
Yeah.
with something in between it that represents kind of a vector. They call it ket. Well, sometimes you'll see a ket with an I in it, small I, right? Now that could mean that is the ith vector in the set of basis vectors for the space. It could also mean it is the unit vector which has a 1 in the ith position and 0 everywhere else.
That is a basis vector.
Right. But they'll use it both ways in the same equation.
But you can do that if you're summing, because the sum was only relevant for the side and the part of the equation you're
Well,
in.
what if the second basis vector?
Like,
Right. But Dave, what if
the subscript is contextual? It's bound.
it works? It works sometimes. It doesn't work other times.
Oh yeah.
And the only way you know how to approach it be to understand the physics.
They're sloppy with their notation. I'm not sure if I saw an advanced topologist working that his equations would even, seem valid to me, because he would be skipping so many things.
Right.
That,
But by the time you get to the publishing, you should clean it up, right?
Absolutely.
Instead, they're publishing using a sloppy standard from like 1930.
Well, that also just kind of goes into like how long it takes sometimes for like stuff to catch up like to like the modern ideas and things. Like you see so many new ideas come up to the surface and how to do things, but at the same time, like we're still just using all of these older concepts, like from like the 30s. I guess now we're to the 30s, because like the 30s is almost 100 years ago now. But like, and it's just, but like 10 years ago, it was like the early 1900s and the 1910s that we just couldn't get past these things. And like, so maybe by the end of my lifetime, we'll finally actually see it catch up to the modern time, once we hit about 2060 or something, 2080.
Well, there'll be new questions that'll make no sense at that point.
Yeah, because we'll still be using we'll be using the notation from now.
Yeah.
Okay. So I kind of wrote down in that last one. So can I say physics, that like sort of the problems with the math and the physics is that like physics is sort of like a simulation that the actual math is a simulation of the physics itself, and the physics just isn't relating, the math isn't showing us what the actual physics should be doing. Is that a way?
In that field, I would say yes.
But it works both ways. They find that the math still predicts something that they didn't expect from the physics, but when they point their apparatus and make the experiment, the math was right, even though they did it sloppily.
Mm.
They know how to read it, right? It's a language for them.
Yeah.
I'd translate what Bob was saying about notation as if somebody's like describing a race event, and you have like horses and riders, and sometimes they say Bob, but you don't know if they mean Bob the horse or Bob the jockey. It really isn't even about the content that they're inconsistent in their labeling. To confuse an eigenvalue with an eigenvector is to confuse the horse and the rider.
For sure.
And it boggles my mind that they can follow their own writing even.
Maybe when they were in school, they were being taught a little more carefully, you know.
Well,
There's certain ways in which physicists don't speak respectfully about the mathematics, right? We know the Feynman quote, you know, that physics is having sex and mathematics is masturbating. You know, it's like and this guy was a regular genius and very good at mathematics and extremely facile and used mathematics really productively in ways that people around him weren't, and inventing ways to use mathematics that has questionability to it, and yet it definitely is the way people do the work. They use his formalism from the graphs and turn it into equations. So there's a hostility there. There's something goes on about how formal and how careful we have to be. So what if the infinities blow up? I can get, as George said, the working answer and predict what will happen, in the statistical result. It's pretty amazing. There's a hostility. There's a dynamic there.
Well, what do you guys think about using this particular moment to identify things that we would like to investigate as a group and sort of get a trial agenda put forth? I don't mind saying that I'm really fascinated with the mathematics at infinity, and I'd like to take a closer look at that if I had to pick one.
So, like infinitesimal.
Yeah, the infinitesimal. Yes,
Okay.
Exactly. Yeah.
And transfinite numbers, that kind of stuff.
Well, it actually concerns what I talked to you about, which seemed to have. It was that business with the Basel function. Remember that Basel function business that we did?
Yeah.
And in it, there was these series of numbers to approximate, like a Taylor series, and there was another one as well. And what they did was what happened was they had these two equivalent series, but one, because it was working with a sign, so they had pi in there. And so, but they had these two coordinates that were equal. They knew they had to be equal, but one was concerned pi, and the other was just a regular rational number. So they solved for pi and had it equal to a rational number. And I'm like, what the heck's going on here? You got pi equal to a rational number. That's just nuts. But the deal is that you had that because it was an infinite series. It was part of an infinite series. Now, I remember talking to David about it, and he was like, well, when you're talking about infinite series somewhere in infinity, everything makes sense. And I'm like, well, you say so. But it just didn't make sense to me. But I think that I think there's a lot of stuff that goes on in there. I have a book on infinity and mathematics at infinity, and it's quite interesting. So that would be my suggestion.
All right. Yeah, we did some interesting ones back. Like I remember
back in the day.
Back in the day, there was a book of poetry we did about
infinity,
and I actually found myself like a year or two finding my copy and going through it, and like it's just, yeah, there's a lot of weird ways that like infinity and infinitesimals and transfinite numbers and all that stuff works, and how you can multiply two infinite numbers together, and how it works and all that stuff. So definitely something to consider. Any other thoughts while we're talking about it?
Yeah, I mean, if we could come up with a list of questions or reading things or stuff that were on people's minds that we could like meet up and say, here's the 20 questions that we're going to discuss, then we can definitely do it. Or examples of things that are confusing, specific examples, like in 5 lines, here's something I read and it cannot make any sense. And then we can, all read it or something like that. Or if you have a book that's an entire resource, that might be worth looking at.
Right. That's kind of what I was. Yeah. That's what I was kind of thinking. That was going to be a suggestion at some point. Of course, problems are the biggest one that needs to be found a lot. I know I've still got some of my old books and stuff from old meetups in mathematics, and I would of course, finding problems to actually work on is always something tricky with this. Working with questions is kind of is a good starting point. I'm now finding, because it helps open people up to like talking about things. But of course, if you come to a math group, you kind of expect to do some mathematics. So that's definitely going to be something that is going to have to be found if we're going to do something on infinity and stuff. But of course, like that might just be. It might be something to try though too, with how do you multiply and add and work with infinitesimals and transfinite numbers, and just a basic problem set.
Greg, when you mentioned interest in infinity, one thing that popped in my head was Newton's original papers. Analytica Mathematica, right?
Right.
One of them, he dealt with the nature of infinity. That's where a lot of the calculus concepts of infinity came from. That might be worth taking a reread. Maybe that could be a topic for a month.
Yeah.
Oh my God. I am fine with the idea of doing Newton.
Newton, yeah, right.
I have a secret agenda with that, in that for me, I've been sort of like blowing my own mind and keeping myself awake, thinking about the word not infinity but eternal, and the idea that something always was there and it always will be. So we can always think infinity looks easy when you have a starting point but no ending point. But if you have no starting point and no ending point, it becomes really, it's a level of extraction that can be problematic,
Yeah, if you have no starting point at any point, it becomes infinite.
So anyway, so stuff like that's why I like to think about infinity, and I hope that it will give me some insight into the larger picture. Just like when people say to you, they'll say, people have said to me, and we were in discussions, they'll say, well, what's the story with matter or mass in the universe? Is it an infinite amount of mass, or is it a finite amount of mass? Well, if it's a finite amount of mass, you could probably collect it in one area, and the rest of the universe is empty. But I mean, really? I don't know. So I mean, it's just like, or is it self-generating? We've seen this sometimes with the quantum mechanics of quantum physics, where energy and matter can coexist, so to speak. It starts as energy and it changes into matter, and the matter changes to energy. I mean, don't ask me about the details on it, but all I know is what people tell me, But I found it very interesting, and it's hard to get, more closer to the what's going on. I have a far look at this thing. I'm not really up close to it.
Yeah, I think that since the idea of infinity is really something we invent, which is conceptual, it's same as the idea of a vacuum or infinite space. That when you try to conceive of putting all the matter in one place, you mean you're you can't actually put anything in just a particular place. You know that it actually is affecting everything all around it, and you can't stop that. So you're trying to do something sort of violating the property of the thing you're doing. And, jamming it together gets harder and harder and harder the more you do that, because everything has total energy. And so you're trying to reduce all the kinetic energy to one point. It's like trying to get to the speed of light. You're trying to defeat nature in its own course. So it's sort of like you can't hold that wall of water back. But conceptually, you can do anything in your mind, even if it violates the essence of physics, because you don't feel how you're violating nature's own structure.
Mm-hmm.
I'll put in a word for polio. I'm going to have to tune in on my phone because I have to drive somewhere. I'm going to listen to the ideas. Yeah, polio is cool. Anyway, if you don't hear me, it's because my phone doesn't always work when I'm in the car. Let me in if you see me coming in, okay? Thanks, guys. Good to see you all.
Yeah,
Yeah, the issue of polio, we've been working through this for like 3 years now.
Mm-hmm.
And we just finished basically chapter 8.
Yeah.
Part of the philosophy was CJ, being a real comprehensivist, wanted to tease things apart in minute detail. And I would recommend that, and I think I put this in an email, that we might want to continue doing polio, like a couple chapters a year, with stuff inserted between it, which is what CJ was doing. So, and not spend more than like a month or two, 3 max, on a chapter.
Mm-hmm.
Because last one we spent like 6 months, and I think we were all burned out on it.
Well, that was my problem with that whole thing, is that being a model person, I would like to project me finishing the book, but I'm not quite sure I ever would, because if you go through the book, there's a second part to it.
Yeah, there's a second book. Yeah, volume 2, right? Right.
And personally, I've been too intimidated to actually read the second part, but the title looks pretty good, and I don't know. I'm guessing that you don't need to have gone through the entire first part in order to get to the second,
Yeah, a lot of what's in the book is self-contained, the chapters.
Yeah, this is a patents of plausible inference. That's
right.
Kind of interesting.
So,
like
Sam was saying, you need to do math when you do a math meeting. You do some problems or something. We could maybe do this and not do all 90 problems at the end of the chapter.
Yeah, I and the couple that I did show up to for the polio ones, because I noticed when I was like getting back and looking at this that the we would see a lot, or there would be a lot of people who'd show up for when the chapters started. But the ones that came afterwards were really more of these more of these problem reviews, and I don't know, with this format of being online, it would be interesting to see how things can go with that. But yeah, it's I don't know. I'll have to work. It would be something to work through and check out. I was saying earlier, and I don't know how many people caught it. It's I would like to kind of, for myself, because I got into chapter 8 after I think the last chapter I did was chapter 3 or 4, and where everybody was at and talking about was a little far above my head. So I might try to do faster reviews of the earlier chapters that don't take long periods of time for, A, because we've got something to work with that people are familiar with, but B, Yeah, just to see if there's like a way to like kind of condense the chapters down into more of something more manageable and bite size as opposed to spending a couple months doing it. It was a way to get content out for sure, but that's something to think about.
Right. The other question, Sam, would be CJ did a lot of work coming up with the questions, the agenda, those kind of things. Uh, for something like polio or reread a paper like one of Newton's papers or something like that. Um, do you want to share the burden? Maybe have somebody pick a meeting that month and let them come up, read the thing in advance, and come up with the questions and kind of agenda. And
Totally. I will
so
totally
this is
would
not a full
love.
time job for you, basically.
Yeah, that's exactly it. Like I really, and we'll have to work that out going forward to see how to actually, share the burden and do it. I remember like years ago when I talked about it with CJ, how do we? Because I think at the time he was sort of like wary on the fact that like people would actually like go through with it and do it, and then we would just have like people doing it. And so probably I guess to do something like that, I'd probably find like one person who wants to try it and then have a backup in case they fall through.
Right.
But yeah, no, I would love to kind of open it up for like other people to try their hands at, because especially like you guys have been doing this now in this group for like years now, because of course I recognize all of your faces and I haven't done this I think since 2017.
Right.
And you guys have been here for earlier, so like I wouldn't mind seeing what you guys would actually like to try and do, and we could uh, see what's possible and maybe even come up with new schedules and stuff like that. I gotta get in touch with Jeannie at some point too, because I don't know how the meetup is being paid for at the moment, and I haven't actually reached out to her and asked questions about that, because last I knew it was meetup.com is like I think like still like $16 a month or something like that. And
Right.
last I knew it was attached to CJ's card, and that was why we were doing the original like dollar donation when we were doing that. And like of course I don't want this project to like drain any sort of account that she might need or something.
Yeah.
Sure. Sure.
So I'll have to actually reach out to her at some point and like see if she's aware of like what's going on in that sense.
Right. And I'm not sure if CJ had some kind of deal with Meetup since he ran more than one, where the expenses were cheaper because it was spread between several of them or something like that. What kind of pricing he had? Brings up another question. Now COVID is kind of waning. In-person meetups. Well, actually, that wouldn't work for you, Sam. You're in Vermont.
Yeah, we'll have to see
How's
how that
that
one
going?
goes, because I was thinking about that today, because like I love the fact that this is online now. I was kind of I wanted to like do more and more online stuff like back when I was doing this, so like to have this to like now that we're in a place that we can do this, it's great. But like, oh totally, I miss hanging out in a coffee shop and like just talking about mathematics for a couple hours. I mean, of course, now that COVID's over and I can feel way more comfortable about traveling again, that might be something too that like I can like even just plan on like one or twice like a year to like come down in Philadelphia and just make something out of it, and we can just like pick a point and do something in person. So yeah, totally. If other people are into the idea of like possibly doing an in-person meetup, I would not be opposed to that.
Okay. Do you ever actually come down to this area for other reasons?
Yeah,
Yes.
I was down in Morrisville, Pennsylvania, which is outside of Trenton last year for like a month or so. I
Oh,
still have
okay.
family down in Kennett Square. And so whenever I'm down in the area, I love going through Philadelphia because like it's just it's such its own city. So I do still kind of come down there every now and then to do stuff. And like, I mean, now that like travel's open back up, like I am I am 100% for traveling.
Right. Okay.
So we've got. So I'm just kind of trying to keep track of stuff. So right now, I've seen ideas on like possibly working with infinite numbers or concepts on infinity. Um, we were talking about maybe ideas about Polya going forward, in-person meetup. Something I wrote in my notes for Infinity and something that I'm interested in is I just kind of wrote down strategy on dealing with Infinity. And of course, that kind of fits into stuff that I've kind of got a little bit into chess over the last few years, and like chess as a concept of like dealing with end games, beginning games. How do you deal with the fact that like there's so many possibilities in terms of the middle game too? So like I don't know, would anybody be interested in like concepts of like dealing with like strategies and like logic on that point?
Yeah, I'm a chess aficionado.
Or even more general, just game theory.
Yeah, there you go.
Game theory is good, yeah. And of
Yeah,
course, I think Greg mentioned earlier something about graphs and sociology. So
that was
game theory and graph theory would definitely be something.
that
Or
was
no, maybe it is George.
David. David did
Yeah,
that.
that actually, but George gave me a book,
Well,
Kelly's Graph Theory, or Kelly Graphs. I thought
Kelly
some of that
graphs
might
is
have
a
been
good
a
one.
chapter of that.
Do you know what the book is called out of curiosity?
Hey, George, the book on Kelly Graphs.
It's called Groups and Their Graphs. Let me see if I've got it handy. Yeah, I do.
Yeah, there it is.
groups and their graphs.
Yeah, and of course,
And
some of this stuff might be
I
really
would like to.
interesting. Oops, go on.
I'd like to suggest going beyond being less finicky than CJ about property rights. This book is 60 years old. Both the authors are dead. I think there is no problem except with whatever greedy publisher with us just sharing PDFs of individual chapters in a small group. In fact, legally, that comes under educational use.
Which fits the fair use doctrine, right?
Yeah. So this whole series is a perfect example of the kind of books that we could go over. They're designed for either freshmen or even more advanced high school students, in that they're self-contained, don't bring in a lot of baggage of advanced math, but rather lead you into advanced concepts like groups or graphs. Or there's also a book about infinity in this series. I just think that we can find more resources if we're willing to use the fair use doctrine.
We did a lot of stuff earlier. I remember back with stuff. In fact, I think it was part of the reason why we went for Polya, because it was old enough that it seemed like it was easy to use. And CJ had a few books he suggested to me way back that I wanted to look at the time. And of course, I don't know if I'll ever remember what they were, but they were based more in calculus and analytics and written in the 1920s. And it's it's a great little gold mine to use older books like that. I'll definitely check out Groups and Graphs, and I would love to see, now that you guys have been doing all this stuff more and more over the past couple of years, it would be really interesting to see like what kind of problems people can tackle. I think it's gonna be tricky too, because like of course, for myself, like this is me getting back into like trying to get back into learning mathematics, as I'm doing a job that I like when it involves concepts of strategy and statistics and stuff like that. So like definitely I want to get back into this, but at the same time, I want to make sure that like there's a couple down the road that are going to be a little bit more accessible to beginners as well, because that was because Polia is great, and like I don't know, I remember one of the last few things I was working on in the group was like people approaching generating theories or generating functions. Whereas I would love to relearn my generating functions. That is definitely something that's a little like it can put people off a little bit too about joining as much and like jumping in.
I remember that was a good topic, very interesting, and that's the other thing. That's like I'm not saying this as what it should be, but all I can tell you my feelings about it, which was when we were doing prime numbers, and then we went in, and I think I remember you were there then, Sam. And there was I forget the guy who did this, but there was a formula that he generated that sort of gave you the distance between one prime number and the possibility of another prime number coming up. And what I liked about it was that it seemed I was like fascinated by it. You know what I mean? It tickled my imagination, and I really wanted to look at it more closely. And I mean, that's the kind of thing that I liked about this group was there's so many things that that was new and amazing. But the only problem was that sometimes we dwelled on it a little too long, and unfortunately, when you came up against something, I mean, there was a couple of guys there that were really good, and they could get through these problems without very very little effort, it seems. And I remember, writing down their solutions and so forth in the hope that somehow it would stick. But but I think that's the other part is that when we come up with a problem, I'm big sharing because I'm on the lower end of the curve, so I would be want to profit more from that. But I think sometimes we all can be profit from something that we see that other businesses don't. So I'd like to see that worked into the agenda of the meeting.
Yeah, and I'll put this out too because like I've already gone back and like as I'm going through the meetup and I was looking at stuff like there's a lot of older meetups too that have caught my eye and stuff I wouldn't mind talking about. Like I do remember some of that stuff we were playing around with concepts of prime numbers and stuff like that. I do kind of remember that one. That was I think that fell under like some stuff we were doing on number theory because of at the time, and that was a lot of fun.
Yeah.
We did an old book on information theory too, and I've been thinking about that one a lot. And if I can find my copy of it, that might be something I want to go back to because I'm working. I mean, it's for my own thing because I'm thinking about stuff that like would help me because we had like we used to we always got like a lot of like people who sort of ran the gauntlet of where their skills were at in mathematics, and it was nice sometimes because you did have people who could come in and like do these harder problems, and then it would just be sort of like the group of us just sitting around and like trying to figure out like, well, how did you get that answer? And like, and that's the reason why I can even do any of this stuff at the moment. Like where I can even wrap my head around it is because of how the group discussions worked, and we could get people in on things and help out each other and like sort of help out with each other, and sort of if one person got something, we could sort of work together for a little while to see like to help other people maybe start to wrap their heads around some of the problems.
Exactly.
I have a couple thoughts. I've batted them around with Bob and others. I think that we need to split the meetings into two kinds. Like have like a regular, more social, lightweight thing where we could even just talk about cool thing of the month that showed up in the news or whatever. the reading group problem solving kind of things should be a separate track. One thing I noticed in the years I've been involved in is that even when we were doing this live, let alone hybrid, people would show up. We're in like part 37 of chapter 80, and they think this group is not for me.
Mm.
So I like the idea, and other groups, even more technical groups, do this. They have like regular meetups which will cover a topic, a guest speaker or whatever, or even just a hour working on problems together. And then the book club kind of sessions would be on a side track. A group of people want to work on something in depth. And that's one of the ideas. My other idea is that we could